It costs that much 'cause it takes me fucking hours. It costs that much 'cause I don't have superpowers. So you need to pay for my skills 'cause exposure doesn't pay the bills. It costs that much 'cause it takes me fucking hours. You need to pay for my skills 'cause exposure doesn't pay the bills. It costs that much 'cause it takes me fucking hours.
Tonight, Robert Moore joins us. He is from the University of North Dakota's Department of Physics and Astrophysics. We're going to be talking about the James Webb Space Telescope. Is there a universe inside every black hole? Is Betelgeuse about to blow up? Why are these people in space? Tonight on Ultras, whatever the hell this show is called.
Well, if there's a thing.
All right, welcome back, everybody. It's your Uncle Warren here, and this is Mundus Ultra. And we've been away for a while, but we're back, at least for tonight, because it's a very special episode. I got a good friend of mine here, Robert Moore, is going to be joining us here in just a moment. We're going to be talking about all kinds of cool stuff that's been happening, or at least been in the news recently in outer space. So I wanted to pick his brain about certain things and get his opinions on what's going on. So, but if you are new to this channel here, please like, share, and subscribe. We like to grow organically like fruit, but we don't want to turn brown. So I don't know what that means, and I really don't know where I was going with that, but just subscribe to the damn channel, all right? Be done with it, all right? Or the angry cow comes to your house, right? See, on the other show we got chickens. On this one we got the angry cow. So anyway, we got Dabby Dabs in the house. What's up? And Pacheco Rowe, good to see you. One of our producers here. Ed Heller, be sure to check out Chicago Corner. Tuesday nights, Ed is the host, and on Friday nights, our buddy Jerry takes the helm, but they are the News Brothers. Good to see you. Like we got Shelly here and Shake and Bacon up there in the Northland. Good to see you. Folks, we got a really special show tonight. There's a lot of crazy stuff going on with like UFO stuff related type stuff in the news, the government coming out with all this kind of information about UFOs and stuff. And then there's also the talk of like commercial space travel, what's going on up in space, and then far on beyond what's going on is the star Betelgeuse gonna supernova anytime soon. There's a lot of stuff going on, plus the James Webb discoveries, which kind of throwing some physicists for a loop with some of their thinkings about it. But let's not bury the lead. Let me bring in my guy here, Robert Moore. Good to see you, brother. Thanks again. Now, just a reminder, that Robert was on the show last year, I think, on the Extra Bull Alive, and we talked about all kinds of good stuff like Earth stuff, and then we went out into space, talked about Apophis and all that good stuff. So it's really great to have you back, man.
Glad to be back. Always enjoy talking with you. I mean, we've done it since when? Let's not go into that.
Many moons ago.
Many moons ago, yeah.
Back when the Earth was young. So
dinosaurs walked the Earth.
And now they still do. Here we are.
Right.
But we just have better tailors. That's all. That's it. Hey, gamers here. Good to see you. Yeah, so the gang is all here. We got Jim over here on Rockfin. Good to see you. Also want to remind folks we are on Rumble tonight as well. So just look for Extra Bulla on Rumble there. Give us a subscribe there too. We're only 2 away from 100. So, hook us up like cable if you don't mind. So anyway, enough of the commercial stuff here. Let's get back to brass tacks here. So let me go ahead and set this up here. Let's talk about space. I mean, we're going to be talking about space all night pretty much, right? So
right.
Which is fine with me. Because we could talk about, I mean, you and I could talk about space like for hours, right? But we both have jobs. And yeah, so anywho, yeah, so so that's how that works. Give me just a second here. Let me set this up. Okay, so in space I think there was a record set like not too long ago of let me see what this is here. Oh, just one moment. So new record, 17 people are in Earth orbit at the same time right now. And I think this was last updated a month ago. So let me see if I can bring this up a little bit.
I missed that. I ain't gonna lie about it.
Well, I didn't, and this is how dumb I am. I didn't know there was a Chinese space station up there.
Oh yeah. They are not part of the ISS, so
Right. It's like a separate thing. There's Shenzhou 15 and 16. Oh, Shenzhou is the name of the space station, right?
Right.
Okay.
I did know that.
Right on. No, yeah. I didn't.
They like running a competition with the ISS and what they're doing, and the fact that it's Russia and Japan and the US, and China doesn't like to be left behind, but they don't like really joining in with everybody else either. So,
well, this goes on to talk about. It says the total number of people in Earth orbit now is at a record high, though only for a short time. It says with the launch of China's 3-person Shenzhou 16 mission on Monday, that was May 29th at 9:30 p.m. Eastern. The population in orbit grew to 17, and the previous record set during the privately funded Inspiration 4 mission in September was 14. So, why do I bring this up, right? So, it seems like, Rob, more and more people are getting into space. And unfortunately for us, I don't think we're going to have that Star Trek future that that some of us wanted, right? I don't think it's going to happen.
Unfortunately, no.
I think it's going to be more of like what it is in Alien, right? All commercial vehicles, they'll get the technology will continue to get better and better where they can go further and further. The next, they're going to be mining the asteroid belt or some, body of asteroids or something like that, So, I mean, what do you think about it? Do you think that's what's going to happen?
I think that's exactly what's going to happen. I mean, there are several government-funded programs, much less corporate-funded, looking into how to profitably mine asteroids. And the thing about even the government-funded is the government can't own patents or anything like that. So anything they develop or discover pretty much is turned over to the private sector anyway. This is something a lot of people don't keep in mind. Uh, so, you know, I think it's only going to get snowballing. I mean, you've got Blue Horizon, you've got Ad Astra, you've got SpaceX, you've got Virgin Galactic. All of these that everybody's heard of are trying to get into space and launch satellites. And you've got 2 or 3 of them that are already talking about their own asteroid missions, trying to work on doing just that, mining. You know, I can see pros and cons for that. I mean, one time I got to admit I was feeling kind of froggy and jumped, and calculated what would happen if you added all the mass in the asteroid belt to Mars. And the answer is it wouldn't, you know, make a decimal point addition to its mass. So it's not a matter of we're adding to the mass of the Earth or anything like that in any significant way, because Earth's, you know, over 4 times as massive as Mars. So, you know, I'm for it, but at the same time, I kind of got to go, who's doing this and who's going to make the profit off of it? You know, is this going to be done for the benefit of mankind, or is it just going to be, you know, for the benefit of Elon Musk and Jeff Bezos? Haven't they benefited enough?
I know, right? Let me see here. They say they're not hearing you very well.
Okay.
So I'm just trying to boost you up here, Sil. Give me just a
Sorry
second
about
here.
that.
We do this live. No, that's not your fault. This is what we call live television. So
right. Well, I say it's partly my fault because I don't have the best headset, and I'm beginning to find out that it's dying. So I'm going to get me a new one at some point.
Yeah, I think you know what I said. Put your microphone a little bit closer to your mouth there. I think that might be it, because the kids are like, yeah. Now I want you to sing us love songs from the 80s. Yeah,
really.
My endless love. Do 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 do. All right,
I've forgotten all about that song. Thank you so much.
All right, thumbs up from Shake and Bacon, where everybody says it's better. All right, good. Because we want to make sure everybody hears what you have to say tonight. The whole thing with the thing in space and the people and the Glavins, you know, that's all the little appetizer for tonight's buffet of delicious space talk about stuff that's been in the headlines recently. So yeah, I think, you know, these commercial, like I said, these commercial flights are only bound by the technology that allows them to do even more and even more. So, like, you know, what do you think, like, in 100 years it's going to look like? Ballpark.
100 years. That's kind of hard to say. I don't think we'll be too much further along as far as everybody getting into space or anything like that. I do think there'll be more benefits coming of it, and more obvious benefits, because what a lot of people miss is the stuff that's invented to overcome challenges to get into space and to stay in space and to work with space end up benefiting all of us. I mean, from things so esoteric as cordless power tools and microwaves to, you know, better microchips and everything for computers, which we're currently working with, right? Mm-hmm. So, you know, people often sneer at, you know, they spent $1 million to get a ballpoint pen when Russia used a pencil. Well, the thing is, pencil gives off graphite that is highly flammable, and that's exactly what you want in a high oxygen environment, right? And it was Mr. Fisher Pen Company, who put up the $1 million. So, and then how much has he made since then, or his company made, selling pens, selling that technology? So, you know, people often go, what's the benefit to me for Elon putting up these satellites or sending up these rockets? And it's like, immediately, probably not a thing. Down the road, 100 years from now, who knows?
Yeah.
Well,
I mean, obviously,
so I ain't getting up on a soapbox like that. But
no, I was going to say, I mean, yeah, unless Elon pulls a Futurama and sticks his head in a jar, he's probably not going to be around in 100 years. So, like,
Right.
who is there an Elon Jr. in the mix? Is there like someone waiting in the wings to take that place? I mean, because Jeff Bezos ain't going to be around forever either. Who is the next generation of people that's going to be doing this kind of stuff?
And the thing is, there's a lot of people trying to get into space right now. There are a lot of private space companies. I mentioned a few of them a little bit earlier: Ad Astra, Blue Horizon, Virgin Galactic, of course, SpaceX. And I think these companies are only going to grow in what they're doing, how they're doing it. I have to admit, I will say in 100 years, space will probably still, as far as tourism is concerned, probably still be the realm of the ultra rich. But at least it'll start being more common. And, maybe there'll be a few giveaways, to Floston Paradise. How old is that movie now?
I'm hoping for Pluto Nash. I'm really feeling for a Pluto Nash kind of thing where we're like jumping cars on the moon and stuff like that. I want Dukes of Hazzard on the moon, Rob. Just where you just keep going up and up, and then all of a sudden you're in space with Elon's car that's up there.
With the dune buggy, yeah. Unfortunately, I think we're going to wind up more with, as you said, Alien or Fifth Element, as far as space is concerned.
Yeah.
I
mean, as long as it's money, if it's profitable and then the technology's feasible enough to do it on the regular, I mean, you know.
And the technology is getting there. I mean, we're had the first successful deployment of a solar cell. So getting to the outer solar system more regularly, as well as potentially sending a probe to the nearby stars like Alpha Centauri and Proxima Centauri, are now not off the table.
Right.
So, we're a lot further along today than we were in 1969 when we went to the moon the first time. But, why haven't we been back? Well, because there wasn't a Russian scare to drive the 25% of the budget going to space exploration. So,
yeah, that's what they want you to believe, Rob. But we all know the real truth. We know what Buzz Aldrin saw. We know what he saw. I know he's a bit of a drinker, but he tells the truth sometimes. So anyway,
okay. They saw this black monolith, and it was playing.
No, stop it! You just ruined everything. This was Christmas. No, you're all right.
I'm sorry.
But I think the last time we talked about the moon, right? Because like commercial flights and stuff like that going to the moon because of helium-3, right? That would be the reason you would go back to the moon if you had the technology to be able to keep that fine moon dust out of everything. That's the technology they need to invent first, right?
I agree. You've got to keep the regolith out of everything. We need to get workable fusion reactors going. And once we do that, I mean, people don't get it, but we've got the technology now. We could beam energy back from the moon to Earth.
Wow.
So, microwave transmission.
You can wait. You could beam energy from the moon to the Earth with how does that process work?
Okay. Bottom line, you send it as microwaves. You send a fine beam of a collimated, as they term it, and narrow beam of microwaves back to Earth to a big receiver dish. And those microwaves, just like we can convert electricity to microwave, we can convert microwaves back to electricity. Your car's radio kind of or your house radio kind of does this already, right, but on a very, very, very minute scale. So the technology has been there. I mean, Nikola Tesla showed us the way. Wireless transmission is definitely possible. It's just, where's the money in it? I mean,
well, yeah.
In the end, that's what, if you got wireless transmission of electricity, who needs your power company, right? How is all this paid for then? How does somebody make money off of it? And the answer is, the only way to really.
That's what Tesla. That's why Tesla he failed because I think at the time J.P. Morgan was backing him when he was building the tower.
Westinghouse. It was Westinghouse.
Was it Westinghouse? It was Westinghouse?
Yes.
But then Westinghouse wanted to put a meter on it, and he wanted to make money
right.
off of it. And Tesla said, no, this is free energy for everybody. And Westinghouse said, well, no more money for you.
No more money for you.
Yeah. And then what was the name of the tower? I think it was somewhere in New York. That
it was somewhere in New York. I don't remember the name.
He built this huge tower that somehow. What was the tower was going to be like? It was supposed to radiate like free electricity.
It was supposed to radiate. We imagine anyway. It would have been radiating microwaves or radio waves.
Right.
You'd have your receiving antenna. And the antenna on your radio works by the electrons start vibrating with the radio signal, which produces a current. So, like I said, we know how to do this. We've known for a very long time. Putting out a usable enough quantity so that you don't cook everybody starts becoming the problem. But that's why I'm saying you put a big dish on the ground, you beam it from the moon, it's converted to electricity and sent out by the wires. So it'd still kind of be wired, but theoretically we should be able to figure a way to more efficiently collect it at site. And so your toaster just has essentially an antenna on it that picks up this ambient energy field and cooks your bread. And, your car then runs off of the ambient energy field. Then again, we've got an easier way of doing that. Instead of running a car, we can run high current power lines underneath the road surface and have coils of wire under your car, bushings, and charge as you drive. Because
how would you do that? How would you do that without electrocuting anything? I mean, how could that? Would that energy transfer through the road like wires? I mean, obviously wirelessly, but but it would be safe.
We do an experiment in our physics labs where they take a magnet and move it around a coil of wire, and it produces a current.
Right.
So a coil of wire with a current running through it produces a magnetic field. So the wire underneath the road is got a current running through it, which produces a magnetic field, and then the magnetic field runs through the coils that are on your car, producing an electric current. So,
all right.
Technology we know about for a while.
I have one concern, Rob. All right, so you and I are both from the South, so and sometimes you're going to get out and pee when you're driving. So I have this. If you peed on the road, on this electric road, now we learned from Ren and Stimpy, don't whiz on the electric fence, but can we pee on the electric road?
Yes, because it would be under the road surface. What I'm talking about would be under the road surface.
Right. It would
not be up on top.
What if it's Chicago with potholes? That Ed Heller in the chat, he's in Chicago. He gets that joke.
Okay. Or Louisiana. You're right.
Okay. All right.
Or Louisiana or Florida with the sinkholes.
Exactly.
Yeah.
They pee on the roads in Florida. All right.
I would not pee on that road at all.
No, I don't
In
blame
Louisiana or Florida, you get a alligator chomping onto something you don't want
you.
chomping
Yeah, I
on.
know, right? Old Boudreaux, he sure do like to take a bite. Yo, can't get in the skiff quick enough. All right,
Woo!
so that was
C'est
our
bon.
app. That was that was 30 minutes. That was a nice nice
Wow.
little appetizer. Did you enjoy that? That was
Cool.
fun.
I enjoyed that. That was fun.
Okay, cool.
What's
All right, so
next?
that's the set. I know, right? What else did you bring? All right, so great movie of the 80s, not so great star in the sky because it's about to blow up. Ladies and gentlemen, introduce Beetlejuice, and then it appears. All right, so
There it appears. Yeah.
this is the odd supergiant. Beetlejuice is brightening up. Is it about to go supernova? Right.
All right.
So,
And that.
You want to go ahead and tell? What do you know about Beetlejuice and what's going on recently?
Okay, I know it's a red supergiant star in the constellation of Orion. So come the wintertime, we'll be able to see it easily. It's brought a lot of notoriety because last year or the year before it dimmed significantly, and now it's brightening. And in addition, they're finding evidence in its spectra, which any astronomer, you're going to hear the term spectra quite often, because it's what tells us what things are made of out there. Bottom line, every atom, every molecule, everything in existence has certain colors, certain wavelengths of light. And by the way, when I say light, I mean everything from gamma to radio waves, not just what we see. Everything gives off only certain colors of light. And so we can identify from which colors are absorbed or emitted what is there. And what they found recently is that there's evidence that carbon burning, carbon fusion, which you probably all heard about hydrogen fusion, where four hydrogens come together and make a helium atom, right? Well, when the star runs out of hydrogen, it can start fusing the helium. But it doesn't get as much energy out of that reaction, so it burns through the helium much quicker than it did the hydrogen. And the helium fuses into things like nitrogen and oxygen. And then if a big massive star like Betelgeuse, nitrogen, oxygen, carbon, it'll start fusing those atoms into things like silicon, nickel, and iron. And what they've recently found is that there's spectral evidence that Betelgeuse is running out of carbon. Now, why is that significant? Well, as I mentioned, carbon and everything, and nitrogen and oxygen are fused into heavier elements like iron. Iron is the bottom of the hill. You can't squeeze any more energy out of things once it's iron. You can't fuse it to get more energy out. It takes energy in. So once iron starts forming in the center of a star, it's doomed. Boom. It's going to explode. Now, we say explode and explode soon. That could still be the next 1,000 to 2,000 years. Mm-hmm. Okay? Betelgeuse is on its way to dying into being a supernova. Absolutely. Will it happen in our lifetime? Probably not. Could it happen in our lifetime, though? Absolutely.
Wow.
So I'm kind of looking forward to it. Having a star beside our sun that's visible in the daytime sky is just going to be so cool. Yeah. And Betelgeuse is close enough to us, and it's going to be a supernova is bright enough that actually we'd see it in the daytime sky.
Right? Didn't they say it would be like as bright as the moon, like a full moon?
I haven't heard any estimates of the brightness, but I would believe that. Yeah.
Yeah. Because the last time this happened was that it was supernova was observed on Earth. I think was like it was like way back, like either the 12th century or like the 15th century, somewhere somewhere in there.
Somewhere like that, yeah.
And they witnessed it, and there was like accounts of it saying that it looked like a second sun in the sky for a little bit, and it was just like really weird. I can't remember which star it was that supernova back then, but I just find that just fascinating because it's like Ed in the chat makes a good point. It said it's about to or already did, we just can't see it yet. Yeah, it could have already done it like thousands of years ago, right? And we'll just now see the light in our lifetime, right?
That makes me think of something. I'm going to have to look something up if I can get my cursor to find so I can come over here to this thing called the internet.
See, we all about some learning on this show. Oh, he wants to know how many light years away is Betelgeuse?
That's what I was looking up. It's 642 and a half light years. So,
okay.
If it's already blown up, it'll be the next 600 years before we'll find out about it. 650 years roughly. If it blew up today.
you think they'd call us, right, and let us know, say, hey, I know you're not going to find out for 600 years, but spoiler alert, boom, boom, bye, holla at your boy, click, And you're like, oh shit, we got 654 years or whatever, 42. Yeah, then. But what happens when it happens though? Do you think like anything? I know you're gonna see it, like you said, it's gonna be you'll be able to see it in the sky, but like what about like physical effects, like any kind of radiation from it? Is any of it gonna be coming towards us? I mean, what do you think?
Well, light is radiation, so the answer is yes. Along with that light will be a nice increase in gamma ray and X-ray flux. The amount of gamma rays and X-rays that hit Earth.
Are we all going to turn into the Hulk? That's so freaking awesome! This is going to be Planet Hulk! This is going to be Planet Hulk! Oh, I'm a practice.
It won't reach the surface, though.
What?
It won't reach the surface.
You mean those 17 people in space will get it? They'll be Hulks. Those 17 people in space will be Hulks.
Yeah.
Just like the Fantastic
sun
Four.
Gives off X-rays, but they don't make it to the surface.
Right.
And so why? Because we've got 90 kilometers of air between us and the sun, including this nice little thin layer called the ozone layer that blocks all of that.
Right.
So
and the magnetic field too, right? The magnetic field.
Well, the magnetic field won't do much to light, to electromagnetic radiation. But the air, 90 kilometers of it, does quite a bit.
Oh.
And
does it like dilute it, or like just kind of like makes it
innocuous? It absorbs it, re-emits it as less harmful, shorter, longer wavelength light. Kind of like what fluorescence does. You hold a UV light over some rocks, and they glow, right?
Right.
So it's kind of the same thing. Those rocks are taking in the short wavelength UV light and re-emitting it as longer wavelength visible light. Mm-hmm. That's what happens in the atmosphere and the ozone layer. The X-rays and ultraviolet and things like that come in, get absorbed as they pass through that thick layer of atmosphere, and get re-emitted as longer and longer wavelengths. This is part of the process of why the sky is blue, is part of that process. The atmosphere scatters short wavelength light very readily. And so the short wavelengths of blue are scattered across the whole sky. And this is why from the ground the sun looks yellow. It's because all those blues have been taken out and spread across the sky. And kind of the same thing happens with even shorter wavelengths like UV, X-ray, gamma ray. It just doesn't get through the atmosphere. People on the space station or anything like that, or the moon, might have to worry about it.
Yeah.
Because there's no blanket of air protecting them. This is why for a moon base, they are one of the reasons they're considering trying to build it into the walls of craters and have it be underground, is because you don't have to worry as much about radiation proofing.
Yeah.
Which is kind of nice.
I think about like how they're going to build if they're going to go back to the moon, because the greedy people want that helium-3. So we're going back to the moon one way or another. It's just a
Right.
matter of what kind of technology we're taking up there. And it's going to be commercial. But you also got the Chinese in the mix too, they got a rover up there now, right? So,
Yep.
so they'll I don't know if you've seen this show, For All Mankind. I believe it's like on Apple Plus or something like that. So basically it's like an alternate history, like if the Russians actually landed on the moon first, right? So then that motivates the United States to say, okay, you landed on the moon first, we're going to land on Mars first. And spoiler alert in the show, like in future seasons, they end up landing on Mars. They're the first one on Mars. It was like a joint mission. They ended up doing a joint mission. It was like a whole thing.
Right.
But they get there in the mid 90s. They get to Mars in the mid 90s, like 28 years ago, right? So
wow.
Yeah. So, and I always thought about that. It's like, had the Russians really gone to the moon first, would we had just like limited ourselves to those Apollo missions and that would have been it? What do you think?
Right. That's hard to say, but we're speculating. I think there's something to that. I don't know necessarily about Mars, but we could have made it a race about building the first permanent base on the moon or something to that effect. The thing about getting to Mars is you're in space for a year and a half. Getting to the moon, you're in space for 3 days.
Yeah.
Okay. Space is not a pleasant environment. And, that radiation issue that we talk about. Radiation poses a danger kind of like any other toxin. It's not just what you're exposed to, it's how much and for how long. And so, there's quite a bit of difference between 3 days and a year and a half. And we still don't have a good answer for how you shield astronauts for a year and a half.
Right.
So
yeah,
that's
where the developing technologies are going to have to come, right? That's right. The thing. It's any kind of advancements in space travel or space exploration, you have to wait on that technology to be developed. They have, but some of the people in the chat are talking about. It's just like, what is the the order of magnitude of how much do you want to get to the moon? What is the reason that you need to get there consistently now, right? So
that's it.
And then you're going to see the alien. Yeah, you're going to see what was it, Whalen Industries, man.
How bad do you want it? That ends up being the bottom line everywhere. How bad do you want it? Because there's a cost.
Yeah.
How willing are you ready to pay that cost?
Well,
and
apparently
the answer
well, go ahead.
The answer is lately is no, we're not willing to pay the cost. So, I'm trying to adjust myself in the screen because my swivel chair. Anyway,
but I just like to dance. Everything's fine. Everything's fine. Okay.
All right.
But like I said, the main commercial reason to go to the moon would have to be helium-3 because they say it's so abundant up there compared to Earth, where it's like scarce or non-existent, right down here. So
helium-3 is what we call primordial. It would have had to, any that is here had to have been here from the formation of the Earth. So helium-4, that happens by radioactive decay of uranium and several other elements. So that happens, but helium-3 is primordial.
Now, what is the primary use in helium-3? Is it rocket fuel?
Actually, it's fusion fuel.
Fusion fuel.
Helium-3 is basically you bombard helium-3 with another proton or with neutrons, and you form helium-4. And helium-4 is a little bit lower on that energy tree than hydrogen, and helium-4 is a little bit lower than that. So in going from helium-3 to helium-4, you release energy. And it's a lot easier to get helium-3 to fuse than it is to get protons, 4 hydrogen atoms to come together and fuse. So it takes lower pressures, it takes lower temperatures, and, you know, to put it bluntly, we can currently fuse hydrogen into helium in Earth labs. The thing is it takes more energy to do it than you get released.
Right.
You start having a good source of helium-3, that equation changes a little bit. And we might quickly be able to develop means of extracting more of that energy and using less to get it. Because like I said, it takes lower pressures, it takes lower temperatures, and you stop needing to confine it in a magnetic field quite as strongly and all of this other stuff. You know, I could do a whole show probably on fusion reactions, you know, but the end result is that helium-3 is a lot closer to helium-4 than hydrogen is. Yeah. And so less temperature, less exotic conditions are needed to get it to fuse on to helium-4 and release that little bit, that significant energy in doing so. And with the moon being sputtered by cosmic and solar rays, there's should be an abundance of helium-4 on the surface, gassed and impressed into the regolith.
Yeah.
So that's why we're trying to do that. The other thing you can do, though, on the moon is you can lay out solar panels.
Right.
And again, beam it back, you know, and you don't have to worry about servicing satellites going in orbit because it's on a permanent base in the sky.
Yeah.
So, far as energy production is concerned, there's a lot of good reasons to go to the moon. As far as other manufacturing capabilities, there's not a lot of reasons to go to the moon.
Right.
Moon is really, really metal poor and everything. A lot of silicon, a lot of oxygen locked up with that silicon because people forget that rock is predominantly SiO2, so silicon dioxide.
Yeah.
So you can cook off a lot of oxygen as well as getting the silicon refined, but that takes a lot of energy to break that chemical bond. So why do you need silicon? Well, your computer chips, you know? So while there's not a lot in the way of metal up on the lunar surface, there is quite a bit of other reasons to go. It's just a question of who's going to do it first and try to develop the technologies needed to make it profitable.
Well, I don't know if you saw that movie Moonfall. It was a documentary actually by this documentary director Roland Emmerich, and
I've heard that name.
Yeah, and basically, I hate to break it to you, the moon is a giant spaceship that aliens came here in to seed the life that's on this planet. And I know, don't cancel me, scientist.
No, okay.
No, that's the actual plot of that movie, though. Seriously, Moonfall is like the moon
really?
is like this giant like spaceship. Yeah, I love some Roland Emmerich, man. Just you gotta suspend your disbelief with Roland Emmerich, man. That's straight pop. But Independence Day, right? 2012, right?
Okay. I liked Independence
Tomorrow
Day,
too.
But Day After Tomorrow. I like Day After Tomorrow, but yeah, it took a lot of suspension of belief. You know, to not sit there and go,
well, yeah.
You know, alrighty then.
Well, yeah, you know what, Roland Emmerich, and I know this is off topic, but we'll get back on it in a second. But I just want to say, Roland Emmerich is one of these directors. You know, he's not going for the Oscar. You know what I mean? You know, he ain't gonna make Schindler's List 2. Okay, that ain't gonna happen, right?
I hope nobody makes Schindler's List 2.
Electric Boogaloo.
And not bad as the movie was. The movie is great.
If it's Schindler's List 2, Back in the Habit, I may watch it if Whoopi Goldberg's in it. But anyway, so And now I'm totally off track. All right, so we got to keep going here. We got other subjects to get to here.
Okay,
So,
I'm sorry.
So you're saying no, that's all me. You're saying we're fine from Beetlejuice and it won't blind us and we're not going to turn into Hulks. None of us, but the people in space might turn to Hulks, right?
Right.
Because
I mean, it'll be a spectacular thing that happened. It'll be like a solar eclipse, except even more rare.
Will we get like auroras? Will there be like kind of aurora things going on around the planet?
Probably not. It's not that close. And anything that would produce the aurora would be traveling at less than the speed of light. So it'd be a few hundred to a few thousand years after we saw the thing, and all of a sudden we'd look up and go, that's a pretty display. Because
that's right. Because we'll see the explosion, right? We'll see the boom. And then, like in 600 or how long would it take for like the physical radiation and stuff? I know the light. Doesn't the light go faster than the other radiation? Or I'm kind of
gamma rays, X-rays, all of that fly at the same speed.
They all go the same speed.
Yep.
Okay, so they'd all be here in 600 and something years, or
650 years, and but I will put it as our own sun. Okay. Light from the sun takes 8 minutes to get here. But there's these things called coronal mass ejections where the sun throws off part of its material, and those can take 3 to 7 days to get to us. So
from Beetlejuice?
No, that's from our sun.
Oh, from our sun.
So 8 minutes for electromagnetic radiation to get here.
Right. And then
but 3 to 7 days for the material, the mass from one of these ejections to get here. So the same type of thing, and it's those coronal mass ejections that produce the aurora. So you've got the same kind of thing going on with Beetlejuice. It may give us, enough of a hit from its mass that's being blown off, but it'll take, light took 650 years to get here. That will take 2,000 or 3,000 years to get here. So,
and for those, go ahead, continue. I'm sorry.
So that's what I was trying to make the analogy of, and what I was trying to get at is it's that solid material, not the light, not the electromagnetic radiation that produces the aurora. So we'd have to wait for that much slower moving material to get here.
I see.
So unfortunately, what we'll get is a light show, and then a few thousand years later, we may get an aurora display.
Well,
I'm looking forward to seeing if that happens, though.
Right. Because you and I are both Highlanders. We're immortal, and we actually, people don't know this. Robert and I are the last two Highlanders on the planet. And so instead of fighting for the prize, we said, let's just live.
Just stick around, see what happens. Yeah.
Just like, hey, how's your family? You doing all right? You eating good? All right, then. I'll see you in another 1,000 years. Right? So
well, we took care of Sean Connery, so bad.
Some things in here don't react well to bullets. But I know it reacts to blades. My liver. Damn, where's me a woman to slap? Sorry. Anyway, I went there.
Anyway.
So, if anybody's wondering why Rob is so red, it's because he is broadcasting from Mars, right? The red planet. So,
right. The reason I'm red is complete mystery to me. It's probably because I'm using a 720p camera, and I have no color adjustment or anything else. I'm working on it. Give me time.
You commoner.
Yeah.
No, it's fine. No,
I'm working with a piece of crap camera and a piece of crap headset. So.
You're gorgeous. Don't go changing. Look, this is actually a good time. Like we're kind of at the halfway point here because we got 2 more subjects to go to. But I think this is a perfect opportunity. I put a pinned comment in here. Robert is also the co-host of Cosmic Pie on YouTube there. So if you nice people could give their channel a like, share, and a subscribe, more conversations like this, free-flowing conversations. You want to talk about the show?
Well, it was just the brainchild of my co-host and colleague, Wayne Barkhouse, who's one of the professors at the University of North Dakota in the Department of Physics and Astrophysics. And he approached me with the idea of us doing a science podcast. So we talk about various subjects. A lot of them are things that have come up in the news, kind of like we're doing tonight. And we have a free-flowing conversation about them. No script or anything like that. We do kind of share our topics with each other, and so we can think about what we would like to say and to bring up and everything. But we talk about things in astronomy, astrophysics, physics in general. This last show, we even got into a little bit about biology. So we try to give all the sciences from love. And in fact, we even mentioned the arts because I've met very few scientists who aren't a big fan of the arts as well, by the way. So please join us. Give us some views. If you like what you see, stick around. If you don't throw too many rotten tomatoes. That's all I ask.
Yeah, I mean, who brings fruit to a show, man? Come on. What is this, the 30s? Are we charging, what is this, the Little Rascals? Are we charging onions at the door so you can go in and watch Spanky's shitty little show in there? Come on, man. What are we doing here? All right, so this
anyway,
is...
come join us. We like questions. We don't get too many, unfortunately, but, come check us out.
Well, you guys just started in January, so, and you're,
right.
Okay, as a veteran podcaster myself, Rob, let me fill you in since you're fresh on the scene, all right? So, no, I'm kidding. So, no, it's like, I think that you're going to be in a good community. There's a lot of like-minded people like myself, who love space and who love talking about that kind of stuff. And, like I said, I find your show, what's your co-host's name?
Wayne Barkhouse.
Wayne Barkhouse, yes. I think you guys have fascinating conversations on there about space, and
cool.
I highly recommend it. So be sure to get over there and subscribe. So hopefully, you'll get the you'll get the Mundus Ultra bump for yeah, right. You're welcome. As Casey Kasem once said, now back to the countdown. So we've got 2 more stories to go tonight.
Okay.
And I think everybody having a good time in the chat. Are you enjoying these topics?
I can see it scrolling. I got to admit, I can't see what anybody's saying there. So.
Well, they're not cursing you out yet, so
Oh yeah. Give it time.
I like to give the chat snacks before the show so they don't get hangry. And start getting hey, why aren't you talking about? There's no So snacks, that's the whole key, man.
And now you got me thinking about that Snickers commercial with Betty White and Abe Kubota.
Abe Kubota, yeah.
Yeah.
Just give a couple of candy bars, man. You don't even have to go full on with the big one. Just give them the little minis, man. Just stay here. And they're like, see. So, James, thank you. Welcome. Good show so far, says James. We appreciate you, James. Thank you. Thanks everybody for watching so far this evening. Probably got another hour to go. And but we got we're kind of building up, right? That's like how you do, you build up the tension. You're getting to the more deeper, crazier things coming up. So
do I need to look over my shoulder?
Oh yes, definitely.
Okay.
Well, you know what you paid your money. You're riding the ride, okay? You know what you know what you signed up for. So
yeah.
Okay, so let's check this out. What about this, Rob? I wanted to ask you, there might be a universe inside every black hole, right? So
right.
Now this is from August 2019. So this is this almost 4 years ago that they were talking about the possibility that well, they've been talking today about how our universe is in a black hole, maybe, right? How that explains a lot of stuff.
Could be. Yeah.
But this was talking about it that like 4 years ago. So this is from where is this from? Discovery.com. So Ashley Hamer is the person who wrote this. So most experts agree that the universe started as an infinitely hot and dense point called a singularity. Wait a minute, isn't that what people call black holes? Right? It makes sense, doesn't it? So what about it? What do you think?
Now, singularities, let's get something clear about them first. Singularities are basically anything in our math where we end up dividing by zero. Okay, that's called a singularity. And so what happens is you get in a black hole, you get all the mass of several stars, sometimes billions of stars, crunched down to zero space because there's nothing to support it that we know of. So that's a singularity. Well, the universe, once upon a time, was all contracted and compacted into a small space. You're dividing by zero. This is why any scientist worth the salt will also point out to you that we have no idea what that singularity is like. Our math breaks down. Our models break down. We have no clue what these things are and what they're doing. That said, we can get close, just not all the way to it. Math breaks down. And you got to remember, in science, it is one of the failings of science. Is we like dealing with things we can put numbers to,
right?
That we can measure, that we can, write equations that mimic the behavior. And in fact, that's what we're trying to get is equations that model, that mimic this behavior and show us, because then we can sit there and go, oh, well, this equation means that this type of thing must be going on. So that's what we're like. That's what we're after. And so we tend to stick with things we can put numbers to. So when the numbers break down, we got a problem. So getting back to the subject, though, yes, the universe could be inside of a black hole. And yes, each black hole could be a universe in miniature. The likelihood of us being in a black hole is very small. Can we rule it out? Nope.
But what's outside of the black hole? What's outside of the black hole? What's outside of the black hole? If we're inside the black hole, if our universe is inside the black hole, what's outside of the black hole? Is it another universe? Is this like a Russian nesting doll? Is this like a universe within a universe within a universe within a? I mean, that's some Marvel. That's some Marvel shit right there, man. You know what I mean?
And again, we can't rule that out. We can say that it's not likely, but there are some things that make you have to wonder. And as for what's outside, we can make zero statements about that.
It's kind of like saying what's outside of our universe, right? I mean, it's like we could say, well, there's a black hole outside of our universe now, but what's outside the black hole? We're always wanting to know what's further and further and further and further and further. That whole we gotta know. So we keep looking. That whole pioneer spirit, man.
Are we in some kind of Russian nested doll? Maybe, maybe not. The thing is if we are inside of a black hole, we can never tell because we can't get out. Right?
Mm-hmm.
But at the same time, even if we're not, we can't yet. We can't even intelligently speak about, is there an outside the universe? Now, we want to speculate a little bit. I always like to point out to people that time and space are a facet of this universe, which means that if you could go outside, time and space don't exist, which means the universe, our universe, to you would now be a geometric point and a temporal point. All times are the same, all places are the same. So you want to talk about a way to go faster than the speed of light, figure out a way to get through the membrane, if you will, and get outside of our universe, because then everything is a point. It's no longer a question of where do you want to go, it's when do you want to go.
Right. Because it's space and time in the mix, right?
Because space and time are kind of the same stuff. They're fabric.
Yeah.
And, you can't take the warp out without taking the woof,
All right, dude. Okay, you ready? What if time is actually matter? What if it's actually dark matter or dark energy? It's one of those things. What if it's one of those things? Right?
Probably not, but it would definitely be interesting.
I mean, I don't know how you would put the two together, but I mean, if time is part of the fabric of space and what makes up space is like what a large percentage of the universe is made up of these dark substances, then, is time anyway affiliated with any of these dark substances? I guess in a way
I like to put it as time and space are kind of the pudding with your raisins inside of it. Everything else is the raisins inside the pudding. Time and space are the pudding. And I'll admit, in studying all of this, that's one of the hardest things to wrap your head around. We're used to thinking of time and space as just these nebulous construct ideas. And to work with a lot of this stuff, you have to think of it as being an actual real thing, like a box you can set on your table.
Mm-hmm.
And it stretches and it is pliable, and it both time and space shift and change depending on the environmental conditions around it or inside of it, I guess you would say. And so this is a field that we're still studying. We're still working on it, and all the ins and outs of it and everything. But yeah, you have to wrap your head around the idea that time and space are actual things. And, we're finding out with our new, LIGO, our new gravity wave detector, that in fact, time and space are very stiff. They're like the springs on your truck. They're very stiff. They're hard to compress and contract. It takes a major event, like two neutron stars merging or two black holes merging, to make it flex and shift and wave. So that kind of doesn't bode well for the idea of warp drive, where we fold space around ourselves and the space goes faster than light, not us.
That's just because we haven't discovered the spice yet, Rob. Right? We haven't found Dune, Arrakis, desert planet. All right, so James Owens here. Good question. How about phases of waves? Like, we only see the nodes of the interference patterns, which indicates there would be other universes out of phase with ours.
And that's what people are looking for. And people have speculated that they found it, that there are evidences of other universes imprinted on the mass distribution of our own.
Right.
Prove it. Prove it becomes the problem. Yes, there's some things that point that direction. The weakness of gravity compared to the other of the forces of nature, which there are four, by the way. There's the strong nuclear, weak nuclear, electromagnetic, and gravity. Gravity is by far the weakest of those four. Well, why is gravity so weak? And you want to know how weak? The force constant for electromagnetism is on the order of 10 to the 11th. So that's a 1 with 11 zeros. Gravity, on the other hand, is on the scale of 10 to the minus 9. That's 8 zeros and the 1. So gravity is freaking incredibly weaker than even the weakest of the other three. Why? And some are actually hypothesizing, notice I don't say theory, hypothesizing that it's because gravity is actually leaking in from a nearby universe. prove it. Demonstrate it by more than just a few nice equations that make things kind of work out a little bit. Demonstrate it. Find something that you can predict and then test that prediction. Now you're talking science. Now you're talking getting a cohesive theory together, because theory means something different to us, we scientists, than it does to the general population. General population, you say you've got a theory, you mean you've got an idea, a thought.
Right.
Theories in science are backed up by facts, observation, and experiment. So, what theory means to most people, we call it a hypothesis. Yeah. So, it's been hypothesized that gravity is leaking in from another universe. And people have pointed to some things like, let's see, what do they call it? The Great Void.
Right. Boots Void.
Real big, open, no mass, no material there at all. Region of space that's out there. That it makes it look like something is leaking in from somewhere else.
What's the big cold spot? There's the cold spot too. They talk about that too. They said that might be
the same thing.
That's the same
one. Yeah, because when you've got a void, it's cold because there's nothing there to emit energy or anything else.
There's no galaxies. There are, but they're like so few of them that you can't even see them. Right? They're so far away from each other that you can't even see them.
Not in clusters, which even our galaxy is in a galaxy cluster.
Right.
So kind of like stars usually form in clusters, galaxies usually form in clusters. And in this great void, this great cold spot, there are galaxies. We can see them there, but they're not in clusters. They're individuals here and there and everywhere. And it's kind of neat because it's like, how did that happen?
It's like when you sweep a floor, right? You get the majority of the stuff in the dustpan, but then there's still the little cracklies left, or little bits that you got to sweep in there too. And I think that's what's in there. Something came in and swept out those galaxies. It didn't take all of them out. It just left the singulars in there. What is it? Is it called Boots Void? Is it Boots or Booties?
Booties? I think that's something else. I think that's within our galaxy. I could be mistaken.
Really?
I don't have the whole catalog of objects memorized, unfortunately.
Hey.
If I could memorize things that well, I'd probably be a biologist and making $1 million a year.
Well, I'm kind of a pervert, so I should be an expert on booties. Hey, am I right? Yeah, all right then. Okay. See? Never mind. Oh, that was terrible. I should never say that out loud.
So,
but there's, and I also read somewhere the other day that, the hypothesis of the white holes too, that are, they think might be on the other end of a black hole. I mean, maybe is that a Big Bang that starts a universe? Oops, spoiler coming up next.
And that's, again, you'll hear me say this a lot. You've probably heard me say something along these lines a lot already, but with white holes, the current thing is show us one. We have not observed one yet. But maybe you're right. Maybe they do exist, but they are the spawning point of another universe. We're speculating, we're spitballing here, but I get
choked up talking about white holes too, Rob. It's okay, man. Just let it out, brother.
But I like speculating again. I mean, I write science fiction and fantasy stories in my spare time, so I like speculating too. It's just if you're asking me the science, white holes don't exist yet.
Right, yeah. I mean, you got to prove it, and I'm one of those people too. I try to apply that in all things in life. It's just like, especially an aside here, the way the climate is, who you believe these days and that kind of thing, so you always want to triple, quadruple, quintuple check your sources and stuff like that. That's why I bring the pros on the show here.
I don't know about a pro, but there's probably a lot of stuff that somebody else that knows more about it would call me down on. But
I'm not bringing that
there's
guy
always-
taking it. I'm not bringing that guy who's taking a dump in front of Trader Joe's on this show. All right, I'm bringing professionals who know what they are talking about. All right.
But,
although I would bring that guy on the show for other reasons, but not for for technical information.
When I was trying to get my PhD, that was one of the funny things we talk about is the fact that when you write your dissertation, you are the expert on whatever your dissertation was. You are the guy who knows the most about that.
Right.
Okay? Till tomorrow when somebody pushed it a little further.
Yeah. Well, I mean, what was it?
There's always somebody who knows a little more.
Right. Well, Isaac Newton was the standard until Einstein came along. Right? So I mean, that's the thing. It's like people say like, oh, trust science and stuff like that about other things, but it's like, okay, I'm like you, prove it. If you have proof of something in science, then you can go from there, right? So it's like you have the proof. This is like we proved this. This is what is it? It's not a hypothesis, it's a theory, and then we prove the theory, and there it is. But it's kind of like saying, like, if you like the core of the earth, right? Is that a hypothesis or is that a theory?
No, that's a full-on theory. And the reason is because when earthquakes happen, they send out waves, right? Okay. Well, there's certain types of those waves that will only travel through solid materials, and there's other types that will travel through solids and liquids. And what happens is the ones that can only travel through solids get down to a certain depth and disappear. We can't see them. There's a shadow cast for that type of wave, which means there's something liquid down in the center. At the same time, the ones who pass through both are refracted, so there's two shadows. The bottom line is I can analyze, and others have analyzed the waveforms of these earthquake waves that are sent out. And we know there's a nice liquid core. And in fact, we even know that there's a nice solid ball in the middle of that liquid. And, people like to say, oh, they can't know that. We can't drill down that deep. Well, yeah, we can. We know how waves behave. And earthquakes send out waves that can be felt all over the world if you've got a sensitive enough detector anyway. So, people like to say, oh, you can't know these things. Yeah, we can, and we do. Just because I can't grab a piece of a star and pull it here into a lab doesn't mean that I can't look at things like spectra and know what's there. And in fact, gravity will affect those spectra, as will magnetism, electromagnetism, and I can make other determinations because gravity affects the density. The bottom line is it's complicated, but we know it. We can tell these things. It takes 8 years to learn how to do it.
Right, yeah. Okay, so if I was to get Aaron Eckhart and that chick that was in $1 Million Baby, and we got our Earth ship and dug a tunnel to the core.
Yep.
That's what we'd see.
That movie. God, that movie. Oh,
that's another one you got to suspend your disbelief, right?
Oh, you got to go further than that. That one I had to turn off.
I watched the whole thing. Oh my God. I'm a glutton for punishment. I love movies like that. That's just that. More, please.
As a class exercise, we figured out. We went online and looked up how much energy is released in a nuclear explosion. Okay, we got an estimate off of the internet of how many nuclear weapons there are in the world. Okay. Do you know what would happen to the core if you set off every nuclear device at the same point on the core? Do you know what would happen? The core would start looking around and going, did something happen?
Who farted?
That's
on,
right.
guys.
Exactly.
You know we were going to be in the elevator. Come on, you couldn't wait 30 seconds. We're almost there.
Half of Earth's mass is in the core because it's iron. Okay, it's iron and nickel. It's heavy. Half of the Earth's mass is in the core, and you're going to take our little nuclear devices and start it spinning again. Right.
Hater. Look, Shakin' Bacon's he's already a convert. He said, after this stream, I'm going to watch the core. Hell yeah. Woo! The core. I know I've seen it before. It's the core. All right, back to serious. We got Snork Y2K has a comment here. The more data points you get, the better model you make. Today we have many monitors, and they are 1,000,000 times faster, so arrays of studies are done and not just one. Of course.
Yep.
So thank you for that. That's
and you've got thousands of scientists mulling over all this data. In fact, there was a program where a whole suite of geophones was taken across the United States and back and forth for like 15, 20 years. So, yeah, we've got incredible tons of data in my own field of space study, especially exoplanet study. Kepler gave us petabytes of data, and we still have people. We'll have people for decades looking at this data because there are so few of us, and so much of it. And yeah, that reminds me of a funny story. One of my graduate classes, we looked at a paper that was patently just, why did they put this out? There's things called list servers where they put out preprints of articles. Mm-hmm. And this was on one of those preprint servers. And we were looking at it going, man, this is horrible. This is full of errors. This is full of this, that. Why would somebody put this out? And somebody suggested, well, maybe they just wanted to throw it out there and get other people's ideas and opinions and bounce it back. And one of the old professors looked at us and goes, why would you do that? There's maybe 10,000 of us in the world looking at this stuff. Why not just send out an email to 100 of them, and it'll be around in the full room in no time. Yeah.
Well, is it classified? I mean, why couldn't you just make it send it to everybody, like put it out on the public and say, "Here, come take a look at this stuff." That like junior astronomers, see if they find anything, right?
Neat that you should do that. There are programs where they're doing just like that. Just that. There's citizen science programs. One that I know about that's been running for a long time now is galaxy classification. Mm-hmm. And they got enough data for ordinary people who had 5 minutes of training on how to classify galaxies, that all of us together are smarter than 12 experts sitting in the room.
Mm-hmm. Yeah.
And so there's merit to what you're saying, and people are trying to take advantage of that and coming up with other things. In fact, there's a program at UND that they're trying to work up a similar program for looking at aurora displays, where they're looking at trying to make it where here's an image. Do you see this type of feature? Do you see this type of feature? And so there'll be hopefully soon a citizen science program on auroras out there where you can go and help classify the features in auroras. We're doing this. We're trying to get help from the general public and asking questions of them and saying, hey, what do you think? Yeah. So there is some of that. Now, at the same time, there's some things we can't ask the general public about because, again, it takes 8 years of training to learn how to read and do fast Fourier transfers to look at the seismic data and be able to pull anything reasonable out of it. It's not that we're being snobbish and exclusionary. It's just the math involved. That said, people have taught themselves this math and this data, how to look at it. And so it's like astronomy. We call them amateurs, but they're doing as good a work as a professional. They're self-taught. By all means, if you want to go in and learn how to do this stuff, go in and learn how to do it. It's a hard road to hoe, and most people don't want to put in the effort.
Well, could you teach an AI to do that?
Yes, you can. And there are people
can do
working
everything.
On that.
Yeah,
and there are people working on that.
But it just seems like that would be, if you're going to use AI for something, it would be something for this huge amount of data that it could probably ingest and analyze a lot quicker than like human eyes, right?
And we've been using that capability for a while now. It's making a leap and bound now, but we used to call it pipelines. And the bottom line, there was a data pipeline where it would look for these features in the data, in the images coming down from Kepler, for instance, the Kepler mission, and look for these type of light profiles of brightening and dimming of the star. And if it saw them, because a computer can sweep through the hundreds of stars in that image in a few seconds, whereas it would take humans days to work with one star.
Right.
So we've had these pipelines of, hey, something's here. Humans need to come look at it for probably around a decade now. But they've recently taken a leap and a bound. And so a lot of the data analysis is indeed probably about to be taken over by machine learning.
Yeah.
And in that case, somebody who's an experimentalist like me is probably okay, because where I excel and where I like being is going into the lab and saying, how would we test that? and this is why a lot of us love the arts, is because it takes imagination to go in and say, how would you do that? We've tried this way of working that experiment and it didn't work. So what do we do now? What do we try next?
Yeah.
And that's what experiments are about. Is experimental science is a lot of effing around and finding out, but you've got to write it down. But you've got to write it down.
F around and find out, but write it down.
But write it down.
But write it down. Oh, that's awesome. All right. So, one more thing before we get to our final subject. So I wanted to ask you, since we were talking about the core, not the movie, but the actual core of the Earth.
Yeah.
Had you read anything recently about, or in your community talked about, the core actually stopping spinning? Was that like an urban myth, or did you hear anything about that?
There is evidence that it's slowing down.
Right.
And there is evidence that was presented that it's slowing down and that it slows down occasionally and reverses direction.
Right.
Now, a lot of people think that it's the inner core, that solid ball that's in the very center, that makes the magnetic field. It is not. It's currents within the liquid outer core that create the magnetic field.
Interesting.
So what is going on? One, we need more data. Scientists always say that. But in this case, it's true. We need more data. Well, major earthquakes don't happen every day. So, we wait for them and hope they don't happen, but at the same time, hope they happen.
Right.
We're weird, sick, and twisted that way. We don't like to see the human devastation that such an earthquake causes. But there is a tendency that we're happy because we're going to get new data now that we can now analyze and look at and add to our understanding.
Right.
So,
it's not like you're reveling in it. But it's like, okay, at least out of this bad situation, we're getting something good out of it.
Good.
It's going to happen either way. There's nothing we can do to prevent it, so we might as well just get the data from it, and then we can use that data to it.
So yeah, I mean, we certainly don't want people dying and suffering, but
right.
yeah, that's unfortunately where we get our data.
Well, I mean, it depends. You know, there's this guy. No, never mind. I'm sorry. I was thinking of somebody else. Hey, before we go any further, I just want to shout out Death to Tyrants and Laura Baza on Rockfin watching over there. Like I said, we had Snort Y2K come in a little bit later here, and James Owens, and Anthony Malecki, and Les Bones, my other producers. A lot of good questions in the chat tonight. We appreciate that. Rob is always keen to impart knowledge on those, and in a fun way too. If I got to choose between you, Michio Kaku, and Neil deGrasse Tyson, I'm picking you. Only because I know you, but I would definitely go Michio second, because Michio and I are like on the same thing, right? Like, okay, all right. I don't know if you guys talk about these people, probably not. But Neil deGrasse Tyson, he's too much of a Buzz Killington, right? He's like, see, Pluto, never forget, right? Booyah, who's your boy, right? And Michio's like, sure, make it a planet, we don't care. He just wants to have fun with the universe, and Neil's over there, well, I don't think this works, So anyway,
I won't relate the story of the time I met Neil deGrasse Tyson, and I stood shoulder to shoulder with him defending the move to say Pluto is a minor planet, not a major. So I applauded that move. So I'm sorry to say.
You son of a bitch. Betray me one day. It was foretold in the scrolls. Yeah.
Now, Michio Kaku, I can tell you, I didn't get the opportunity to meet him because pretty much he gave his speech and hit the door. He couldn't even be bothered to sell and sign his own books he had there
you throwing shade on Michio? That's my boy, man.
Sorry,
what are you doing?
Neil deGrasse is no longer. He's much better anymore.
You are such a fanboy.
I'm sorry. No, he's not much better
anymore.
He's not much better anymore. I understand. When I met him was at the top, the slope up to his fame and crowd pleasing. And he since has peaked, and I understand he's just as bad now. So
much hatred in the physics community. Wow, this is scandalous.
Not hatred. It's like you were invited here to speak.
Man, you're selling over here.
You're selling your books here, and you can't be bothered to stick around long enough to sign a few.
These are rock stars, man. Come on, they're not going to do that.
They are. And they act like it in ways. So,
well,
I definitely prefer Phil Plait, the bad astronomer. He is a great guy.
Well, they always say don't meet your heroes. So, and now that you've spared me the disappointment of meeting Michio, I'm still on the fence with him. But I
hope you get to meet him. I will hope.
Well, he's in my neck of the woods. He's at City College over here. So I could go see him anytime I want. There's no restraining order anymore.
And I hope you get a chance. But
all right. Well, I don't know. If anything, I'd like to see him in passing on the street. I saw Conan O'Brien the other day. He was walking on 56th Street. Yeah. I was just sitting out there just having a nice little break, and he's just walking by with these two fellas. And I was like, that's Conan O'Brien. Yeah, so it's New York. He lives around there. So anyway.
Go ahead. I've got another story, but it's not a related story. So let's go back.
Go ahead. We're free flowing, baby.
Okay.
We're free flowing.
What's his name? Doc Brown.
Christopher Lloyd.
Christopher Lloyd. One time at DragonCon, which I attend fairly regularly, I was waiting for us to get a chain and lock to lock up the solar telescopes in the tennis court at the hotel. And he walks out onto the deck out of the green room, sits down, and lights up a cigarette. Well, I'm stretched out on a bench waiting for that chain and lock to get there and notice him. And I'm like, wait, that's Christopher Lloyd, and sit up. And I noticed that the man was eyeballing me. And I'm like, you know, I'm in his shoes. I'm out here trying to relax, get away from all the fanboys and fangirls, smoking my cigarette. What's the last thing in the world I want to happen? So instead of getting up and going over to him to talk to him, I just kind of gave him a nod. The man grinned at me, nodded back, and went on smoking his cigarette. I loved the encounter, and I'm pretty sure he appreciated it too, that this guy, Brando, did not just come over him and start bugging him while he was trying to relax. So it's like I tell people, interacting with these folks, give them some space, treat them like you would anybody else, and you'll probably get more out of them than if you, oh my God! You know?
Right, yeah, because that's the last thing they want is just like this wall, this tsunami of nerds coming at them, you know,
right.
Just like, I remember it was like the third edition of the Back to the Future comic book. This time you didn't go to the future, you went back to the dinosaurs, and it's like, will you get the fuck away from me? I'm eating a sandwich. Anyway, so,
yeah,
all right,
no,
so
you're
we
right.
gotta get going. We gotta get going. I know we could talk about Christopher Lloyd all night. I met him at Comic-Con in the New York Comic-Con. Well, I didn't meet him. He was in a panel, and I got to ask him some questions. I asked him. He was in this movie called Things to Do in Denver When You're Dead. It was like this ensemble cast back in the early 90s. Oh, great movie. So I was asking him about that, and he was just like, I was on that movie. I loved that movie. Oh, that cast was great. Oh, Marty. All right, so I have this theory, right, that Doc Brown is Reverend Jim on cocaine. And Reverend Jim is Doc Brown, who's just smoked a whole pound of weed. And some acid. Throw some acid in there, too. Anyway, all right. Yeah. So the main event tonight is the James Webb Space Telescope. So last time we spoke on Extra Bull Alive, they had not launched the James Webb, the JWST as they call it, yet. So, and that happened. That they launched it this year, or was it late last year?
Late last year.
So they launched it late last year.
Had to have been sometime last year or the year before, because I did a presentation last year on how it unfolded and everything.
Right.
And last year at DragonCon, we had presentations all about it. So it had to have been the year before that it was launched and that it got into its orbital position. Anyway, that's beside the point. Go ahead.
So the James Webb Space Telescope spots, it goes up, right? And it's this fantastic telescope, top of the line, replacing the Hubble, right? I mean, but the Hubble's still up there, but this is the big dog. This is the alpha of the telescopes up, right? So James Webb Space Telescope spots gigantic old galaxies, and it puzzles astronomers. So let's talk about that for a second. So now
only a second.
Just a smidge.
All right.
So as light is further away, right, it's affected by color, right? So the further away light is, like, the more red it becomes. Do you want to explain how that works?
Okay. The bottom line is the universe is expanding. In other words, there is more space now than there was a second ago. Okay? As light moves through that space, since the space is expanding, the light gets stretched out. It goes to longer wavelength. Well, longer wavelength means redder. Okay? You can think of it as it's a Doppler shift effect. You can think of it like an ambulance going behind you, going by you. You hear it coming, and it's nice and shrill. And then it gets you, and you get that pitch drop. Okay? The same type of thing happens. Because it's moving away from us, the light gets stretched to redder and redder wavelengths. And James Webb is designed to look at infrared wavelengths, which are redder than red, right? So it's designed to look out at this edge of the observable universe type thing. And it was specifically designed to do that. So calling it a replacement for Hubble is, to me, kind of a disservice to Hubble, because James Webb and Hubble aren't even looking at the same color of light.
So it's more of like an accompanying tool, like that they work together, right? Yeah, I guess that's what I meant. Not like to replace it, because it's not like they're going to take the Hubble out of space. It's going to stay there, right? You know.
Well, we're hoping not to. If it gets to where it's not functioning and not usable anymore, they will deorbit it and splash it down in the Pacific somewhere.
Well, how far in orbit is it right now?
It's low Earth orbit, so it's only like 400 kilometers, if that, up.
Really?
So yeah.
Oh, I thought it was way out there. Get away from the
James Webb is way out there because it needed to get away from the heat signature of Earth, the heat glare.
And how far out is the James Webb?
It's 1 million kilometers out.
Oh, okay.
So it's out beyond, further away than the moon is.
Oh, wow.
Because the moon's only 300,000 kilometers away. This James Webb is 1 million.
Oh, wow.
Yeah.
That's great.
So there's no servicing to the James Webb. We don't have a rocket, it had to drift to get out there. A few little jets to give some course correction. And set it up in orbit at that Lagrange point.
You got to get slim pickings on that rocket to get out there and fix it. Like, woo!
There you go. Woo!
So, but I'm sorry. Continue. No, you were talking about the how far it is out there away from all the light pollution and other pollution that is. I say pollution, that the kind of things that might interfere with the readings and stuff with it, right? So, and it's brought back some amazing pictures, right? So as we looked at this again, it found these 6 galaxies, right? And these galaxies formed 500 million years after the Big Bang.
Well, 500,000 years after the Big Bang.
500,000 years.
Yeah.
Wow.
So they're they formed a lot quicker after the Big Bang than we thought possible. Okay?
And why is
notice that's the question. You see, people have took this and are taking this, I guess is the proper grammar, and started saying, it calls into question the Big Bang. Sorry, no, the Big Bang has made predictions that we found are true. The Big Bang we're far more certain of than our theories of how galaxies form. So what this is called into question is our theories of galaxy formation. And maybe not even then, because we don't have spectra on these galaxies, which means we don't really know that they are that old. If they are, they're a lot bigger than they should be. But I will point out, there's 6 out of however many James Webb will find.
Right.
What does that mean? Well, there's always outliers. Like I was considered tall growing up, right? You were taller than me. Does that mean you're the rule or were you the exception? That may be the case with these 6 galaxies. Is maybe they're the exception. They formed up real quick and real large for some reason, but the majority of them didn't. And that's something we've got to find out by getting more data, by getting more images of these things, by getting spectra of them to see, are they really that far out? Are they really that close to the Big Bang? And it's exciting times.
Well, I mean, 500,000 years in cosmic time is a blink.
Yeah.
Right?
That's like 100,000 years after what we call the Dark Ages. There's a limit as far back because at some point things would have been so dense that light couldn't have gotten through it. And we call that the Dark Ages. We can't see anything past that.
Right.
So these galaxies are like 100,000 years after the Dark Ages. If they're really that big, how did they form that fast? That's the question. Holy cow. Exciting times to be alive because, we thought we had a good handle on how galaxies form. This calls all that into question. The Big Bang. The Big Bang is not really in question. There's a few questions about it, but, it made predictions about the composition of the universe, how much hydrogen, helium, and other elements were created in the Big Bang. And we've observed those predictions. So, yeah, there's other factors that have come into it as well. So it's going to be really hard to knock down the Big Bang, folks. Sorry. But galaxy formation, we're just now getting an instrument up there called James Webb that lets us look back far enough to see galaxies forming.
Yeah.
Apparently, it's a different process than we thought.
and that's just the technology we have right now. I mean, like 10 to 20 years, how much further down, in space will we be able to see? And, maybe in 100 years, maybe we'll actually be able to have something that somehow magnifies the actual light of the planet where we could actually have physical pictures, right? But that would have to be some kind of crazy technology to be able to do that from this little bitty pea in the universe, right?
Right. Well, there are talk about there's people who are talking about putting up in space an even bigger telescope than James Webb, which would allow for that. There are people already talking about putting up what we call an interferometer, which is a bunch of little telescopes that act like a big one. But you have to know precisely how far apart they are.
Uh-huh.
So there are people talking about putting one of those up in space because then we can use a whole bunch of little telescopes and mimic the resolving power, the resolution of, something thousands of kilometers across. Mm-hmm. Sorry, I use metric units because, we use metric units. Sorry.
Well, we got Canadians in the chat, so I'm sure they appreciate it, right?
We're already talking about these types of instruments where we'll get you a better picture of what's going on. And this is why I try to tell any young people that might be listening and might be watching, if this stuff lights your fire, if this stuff makes you excited and gets you going, there's plenty more to learn. Join us. Get in here and get after it. Go win your Nobel Prize.
Yeah, I mean, I would think it's a tragedy to me to see so many young people who are just so buried in their phones every day and just lost in that world when they could be looking the other way and seeing, what's out there and the final frontier. It's the final frontier.
I'll put it this way: look at your phone. But look up every now and then too, Yeah. Life should be a nice balance of all kinds of things going on. Smell the roses. Look at your phone. Look at the squirrel running around the tree. Look at the sun and wonder what's really going on there every now and then. Well, don't look at the sun, but you know what I mean.
All right, birds. The scientist told me to look at the sun. Why would he tell me to do this? This is so painful.
I'm blind now, right?
Everything looks yellow. Everything looks yellow. Oh, the humanity. No, well, no. I'd love to see when we were kids, man. We were still seeing Apollo missions on TV, and then they stopped. Then people started getting tired of watching it. Not me. I love watching that stuff, man. Every time a rocket went up, it's like, there was a new mission. More people going back to the moon. It's like
I remember
was
being
like, the
plunked
Jetsons
down
are
in front
here,
of the
man.
TV to watch it.
The
You need to
Jetsons
watch
are here,
this.
man. We're gonna be flying around in like the moon, and like there's gonna be like moon bases and all this stuff. Nothing, man. The only thing we got out of it was that crappy TV show with Andy Griffith called Salvage One. I'm apologizing. I love Salvage One. It was only on there like 6 episodes, but they went to the. Remember?
It was.
Did you ever see? Did you saw it, right?
Yeah.
Yeah, he's a joke man. They ripped off that idea years later with the was it
Ricky
the
Rocket.
well the farmer, the rocket farmer,
Rocket
the
Farmer.
the astronaut farmer.
That was it. With
Billy
Billy Bob Thornton.
Yeah, and he built him a rocket ship in his barn. Yeah.
Yep.
So but
That was a fun show. I liked that show too.
Yeah, it was a good movie.
Yep.
It had who else was in there? Shit.
That
I
I
can't
couldn't tell
remember.
you. It's been a while since I've seen it, so I remember Billy Bob's because everybody was making fun of him liking them French fried taters.
I want me some biscuits and mustard. Mm-hmm.
Yeah.
Oh man, that just brings me back. So see, for those who don't know, Rob and I have known each other. Rob is my oldest friend, and I'm not saying like age-wise. I'm saying our friendship is almost like 50 years, right? Almost 50
Something
years.
like that.
Pretty close.
We
2
met
more
in
years.
first grade. First
2 more
day
years.
of first grade.
We were 6 years old when we met. Yeah, first day
Yep.
of first grade. And I said,
Yep.
and at the time I said, this guy's crazy. And we were besties. We would play Star Trek at recess, and like,
Yep.
and you were huge into dinosaurs and stuff. And yeah, man, great times. James Owens, good. Salvage One was awesome, right?
Yes.
Although, you want to hear something funny? Okay, so one night I'm doing a show, and I'm showing like these old commercials from like the 80s and 90s, right? It was just like some little fun thing I was doing, and I showed the opening to Salvage One, right? Like, the whole
Right.
like when so-and-so was he built this thing in his back, and they told, how back in the day they used to tell the whole freaking story about the show in the open, and then
In the open,
they had
yeah.
right. So I played that on there, and then like 2 days later, I got I didn't get a strike, but I got a warning, a copyright hit for using Salvage One. Salvage One is copyright protected, folks. So if you're doing anything with Salvage One on YouTube, I want you to stop it right now, because you're gonna get in trouble.
You and I are probably the only ones and James, probably the only ones who even remember it.
It is such an obscure. It was only on for like 6 episodes or something like that.
It wasn't even a full season. Yeah.
No, it wasn't even a full season. Yeah, they went to the moon.
You got a strike for that. Wow.
Yeah, man. I was like, YouTube, you suck. And I appealed it and everything. And you would think, okay, they're obviously not making money on Salvage One, so why would they care if I used it, right? And I appealed it, and they still denied it. They said, no Salvage One for you, asshole. Oh, sad face, tears coming out of eyes emoji. So sad.
I can't believe that, because like I said, we've said, it didn't even last the season, and despite having Andy Griffith on it,
it was a great concept, though. It's just like, dude built his own rocket ship,
went and salvage the junk. Yeah,
I'm not a big fan of remakes these days, but I would love to remake Salvage One today, these astronauts or something. They're like this, like a couple astronauts, they get together and they build the ship in secret, and then they're like, because we're going to the moon, they saw things on the moon and they weren't allowed to go back, but they're going to salvage the moon, but they're really looking for aliens up there. See, that's the twist that Andy Griffith didn't think of. Yeah. Anyway, I don't know. I just love.
I agree with you. That would be one to bring back. I would love to see it. Yeah, do some kind of twist with it. Absolutely.
Who would you get? I mean, Andy Griffith is no longer with us. Who would we get to play the guy, the salvage, the junk man? Who would you get?
What's his name? The Witcher, Man of Steel.
You get Man of Steel to be be Andy Griffith? You got him to be the junk man? Who?
Yeah.
Yeah, what's his name?
What's his name? I can't remember his name to save my life right now.
Look, I'm a stoner, all right, so I have an excuse for a bad memory. I don't know what your problem is, Jack. All right, you should know this. Henry Cavill, thanks, James. You're a good person.
I would give him to play the lead role on it.
See,
and I think, honestly, from what I know of the gentleman, I think he would love and have fun with that role. I think he would have a ball.
You mean, okay, so we'd have to really, all right, because the original Salvage one was kind of campy, right? It was a little bit.
It was.
It was a little bit out of that. But you could actually make a really serious, what's a Christopher Nolan presents Salvage One, right? You know, oh, Laura, thank you. She tipped us $2 on Rockfin. You're a sweetheart. Thank you so much, doll. But yeah, Christopher Nolan Salvage One. Let's make those dreams come true.
Point the show in their direction.
Dude, here it is. So you make Christopher Nolan's Salvage One, and you get Michael Caine, who's in all the Christopher Nolan movies. You get him to play the Andy Griffith character.
Yeah, right? I can see that
too. And Christian Bale can play the dude who was like the pilot, right? He was the race car driver pilot dude, right? He could be that guy. And they get him back together.
Yep. Woo! And if we're dreaming of that cast, getting J-Law, Jennifer Lawrence to play the lady.
The lady who was like she worked at NASA too, I think, or something. She was like a fuel she was a fuel expert. Yeah, she was the fuel expert. Yeah. Dude, look, remake that and do a good version of The Greatest American Hero too. Bring that stuff back too. That was awesome.
Bring that one back too.
Yeah.
That was when I was really upset when I found out it had been canceled. You got to admit,
it was so good. Awesome. It was so good, and the music. It was like a great theme song too. That was the thing. We grew up with these TV shows that had like awesome theme songs, like Hawaii Five-0, Sanford and Son, and see. We get together.
You couldn't get away with a lot of those shows, though. Sanford and Son would not work today's audiences.
Oh yeah, Red Fox would be canceled. Red Fox would be canceled in a heartbeat. Half those 70s shows, you could not air today. It was James says, believe it or not, I'm walking on air. Hell yeah.
Watch out, you'll get that next strike.
That's I know, right? Oh, yeah, I know, because I sound so much like whoever that guy was that sang that song.
Right. But that was a great show. I mean, the whole concept of somebody with the powers of Superman, but he doesn't know how to use them because he lost the manual for the suit twice.
I always thought that they would have. I thought like maybe in the early 2000s when Will Ferrell was hot. I always thought that they would have made a movie about it and let him play. I think he would have made a greatest American hero, right? But but then it became, before he became like all over the place and oversaturated with like him. Just Will Ferrell was in everything, and you're like, okay, I'm sick of Will Ferrell. But before that, you get him in there as the William Catt dude. So yeah. James agrees. He said he would have been great. I think so, but at that time period, now he's too old. You got to have somebody young to do it. So
you got to have somebody kind of young to do that. Yeah.
Well,
have the government trying to get the suit and everything. Oh man.
Oh man, awesome. A 2023 version of it. I know, right? Let's make some money, baby. Let's write this tonight. Hell yeah. Oh yeah. I love those kind of ideas. Maybe we will. So, but let me get you out of here. I've kept you long enough. Okay. We're at the 2-hour mark here, brother. And man, I knew it was going to. It's been I know it flies by when you're having fun, man. I'm telling you. And I've been I kind of keep an eye on the clock too, because it's the old news producer in me, man. I can't keep my eye off the clock. So, but even that, 2 hours just.
Wow.
Because you gave us great information. I thought it was a great conversation. I always enjoyed talking to you about this kind of stuff. Because we're just a couple of old nerds who just love this kind of stuff anyway. And you actually make a living off of it. Exactly. And the last 15 minutes of the show, of course, is just like icing on the cake. The chef's kiss, as you said. So
right.
Delicious. So I appreciate you, brother. So okay, so one more time. Like I said, we have the pinned comment here with let me get this here. Rob's channel. Go ahead and tell them about your channel one more time, please. While I put these links in.
Okay. I'm assuming you're talking about the Cosmic Pi.
Yes.
Basically, it's run. We're working out of the University of North Dakota, the Department of Physics and Astrophysics. We're interested in trying to look at topics within astronomy, astrophysics, physics in general, and science in general. And we just have a conversation about what's going on, what these things are about, how they work, and things like that. We've had a couple of guests come on to talk about what you can see in the night sky at this time of year. So, if you're interested in that sort of thing, if it sounds appealing, come give us a look.
Yeah, man, I really do. I think that's great. I think there should be more citizens involved in that kind of thing. If you're going to ignore, look, if you're going to worry about the world that you live in, maybe it's good to look outside of the world to see if maybe there might be some solutions out there, because you never know, right? You never know, and you never know what threats you might face out there. That these kinds of equipment maybe in the future we're able to capture these near Earth objects and stuff that get too close. We're able to like the tsunami system that they have. We'll get like some sort of technology to give us warning. Like maybe we could put probes out in the solar system that detect these kind of things and send back that information to Earth. I don't know.
Yep.
We'll see. I hope so.
And solving the problems, who knows what we'll come up with. You are 100% correct. And
I know, man.
Think outside the box, get creative, get out there, get the juices flowing. And to that end, I will say, don't give up your drawing and your writing and speculating and thinking about all this stuff. But in the end, come join us.
Yeah.
I will always encourage new scientists. I will always I will always encourage new artists and everything else. This is what makes us human.
Exactly. We're losing
in a world full of ChatGPT. This is what makes it means to be human.
Exactly. As I was about to say, that the world seems to be quickly losing its humanity, so we got to hold on to it as long as possible. Hey, Rick, good to see you. He said great conversation. Thanks, brother.
Thank you.
Do. I thought it was too. So, brother, I love you to death. We're gonna do this again more often.
Absolutely.
So
anytime.
You're my space guy. So, next time we have some big news in the cosmos. Obviously hit me up too. Say, hey, let me come on the show. Let's talk about this. Because and be sure to check out Cosmic Pi with Robert on there. Fantastic show.
Thank you.
The most laid back, chill space podcast that I've ever heard, and I totally dig it, man. It's great. It's just like I put it on in the background, and while I play this game, City Skylines, right, where it's like the city builder, and because I'm into that kind of thing. So anyway, and I have you in the background and listening to you guys and stuff, and every once in a while I'll pop over to see what you're talking about, like if you have a video or a picture up there. So it's like good stuff. It's good stuff. Keep it up, and we're all here to support you too. So Anyway, any final thoughts? Anything you got coming up? You want to tell people about, or
I don't have anything. You know, my life pretty much revolves around the highlights are doing things like this, and the podcast, Cosmic Pie, because like today I was cataloging and checking in equipment and trying to figure out where I'm going to put it in the storeroom. Yay. So coming on, talking, having conversations like this, sharing some old times, sharing some new times.
So
Great
you're
stuff.
saying this is a highlight, right? This is a highlight compared to the.
Pretty much.
I'm glad we can help out there. I'm glad we can accommodate you. Give you a little vacation from the humdrum there. So,
like I said, I didn't realize it'd been 2 hours, or else I'd have been going, So.
Great conversation. You stay awake for that stuff.
Absolutely.
Well, now when does your show on? So it's on YouTube, right? And
it's on
so
YouTube.
when is it on? When is it on?
It's we record live every Tuesday. Well, not every Tuesday, because like next Tuesday is 4th of July. We won't be doing.
So the next one will be 7-Eleven, right? It'll be 7-Eleven Day.
7-Eleven Day.
Don't forget to get your free Slurpee.
We do it at 3 to 4 Central Time on Tuesdays. And this is until the start of the fall semester, because with that comes changing academic schedules, and we'll pick a new day and a new time that's maybe more convenient for Wayne and I. And
cool.
But our plan is to keep doing it. We just may have to shift time a little bit. But
well, man,
stop by and see us live. We have a chat like this.
And you guys encourage questions in the chat, right? While you're talking about this stuff, please. Yeah.
Absolutely.
So we need to learn more about our universe as much as possible. And Rob, it's great to see that you're on the cusp of all this, and you know, what you guys are doing, and you know, and taking this massive information that for a lot of us normies, you know, it's hard to comprehend, but you know, you seem to boil it down so well. And make it more digestible to people, and that's how you do it. That's you're a great communicator with that. That's the way you do it. That's what you're supposed to do.
I try. I missed the mark a few times, but I really do. I try, because I want people to know.
Right.
And most of us do.
Exactly. So I appreciate your efforts, and I appreciate everybody that showed up tonight. It was a great crowd, great conversations, and they're great questions too. I appreciate that. So, and I'm, you know, of course, you're a friend of the show, and we're gonna get you back on sometime in the future. Maybe we'll make a regular thing, right? You know, maybe we could come up with you know, we don't have to go the full 2 hours. We don't
have to talk about science. We can speculate some. You know, we can.
Yeah, I'd love to. You
sit
know,
back and go, hey.
I'm glad you said that, because I would like to. I want to get some of us Gen Xers together and talk about, so like I want us to have like the great Star Trek discussion, like how do we get to the Star Trek universe, you know, and have various
viewpoints there instead of the dystopia we're going toward.
Exactly right, the alien universe. We need to steer away from that multiverse and go to the other universe. So anyway, let's get out of here. It's a school night, I'm sure, and everybody wants to get to sleep. So I appreciate you. Love you, brother. Check out his YouTube channel, and thank you everybody for watching on YouTube and Rockfin and on Rumble and on Facebook. Good night, everybody. We'll see you next time. Peace.